Simio users to Simio Sync 2022 Practical Applications. This presentation will review some tips and tricks on how to shift the modeling approach in an existing model from traditional methods to data-driven and data-generated. Large volumes of data are often available to build and drive a simulation model. Efficient and appropriate use of this data is critical to model success. When a project begins, the path forward using a data-generated or data-driven approach may not be clear. However, it is never too late to change to a data-oriented strategy. Simio is equipped with features that will minimize rework and ease this transition. Let's review what a data-driven approach is and how it can be beneficial in your model. With a data-driven approach, data is logically organized into tables. These data tables could be created by importing information from external files like CSV or Excel files, or come from databases, maybe from your MES or ERP system. The objects in the model will reference the data tables. The data table reference is more generic and repeatable across objects. Then, the data tables will hold the unique values and details for each object. With data tables, the model is now easier to maintain and update. There is one central location of information. If we have already started modeling our system, moving to a data-driven or data-generated approach could be intimidating. We want to avoid rework. Simio has a multitude of tools that can assist with this transition. First, let's take a look at this manufacturing example model that has been built with traditional approach. The objects were dragged and dropped into the facility, and properties were updated with manual entry. This model shows the manufacturing area. Parts arrive and will go to a lathe, a mill, and then a workstation prior to being shipped out. Notice there are multiple machines of each type. Each like machine will have similar properties. Additionally, a team of workers is required to run the machines. Each worker team is trained to work on a specific machine or workstation. Each server, representing the lathe, mill, and workstation, requests the worker from a unique list. For example, all 3 lathes request the worker from the same lathe worker list. Let's take a look at the mills. Here, the machines are using a task sequence process type to model different steps in the mill's manufacturing process. The task sequence uses a repeat property group to hold the task information. When we want to edit this, we need to go to each of the object's properties and make changes. These tasks may need to change as we get more information about this system. Also, maybe the task sequences are information we want to experiment with in our model. If the data is imported into a table with a data connector, the data connector configurations can be changed in an experiment. Or perhaps this is information we want to relate to other data in the system. For example, each different entity part type may have a different set of tasks, but all of these tasks belong to the same machine. In Simio, we can easily create data table relationships with keys and foreign keys. Creating this relationship can enhance how the data is structured and used in your model. Moving the task sequence information to a data table could be beneficial for any of these reasons. First, we will want to build a table to hold the task sequence information. One easy way to do this is by using Simio's pre-made table schemas. Simio offers schemas that correspond to all object and elements, properties, and repeat groups. Here, we will want to add the server's processing tasks table schema. When we add this in, we see columns that correspond to the properties in the server's task sequence repeating property editor. However, we already took the time to add this into the repeat group. Do we now have to retype this into the data table? You can leverage the Properties window to gather this information, copy, and paste it into the table. The Properties window can be opened via the Home ribbon or by right-clicking on an object and selecting Object Property Spreadsheet. Once opened, I will find the mill's task sequence information and copy it into the table. Once the task information is in the table, we can apply the table references to our server objects. On the top level of the repeat group property, we can right-click and set the reference to the data table. Then, if the repeat group is opened, we can see that the table references have been connected to each property in the repeat group. Adding this task sequence information to multiple servers is now very simple, and if we want to edit the task sequence information, we only need to go to the data table. If we want to create another mill machine, we would need to input these table references in the server's properties. However, we can create a custom object where these references are the default for these property values. We can subclass a server object and make these changes. A quick way to subclass an object and keep the current properties as the default is to right-click and select Create Object from this. This creates a new custom server object definition, and this definition will retain the current symbols, properties, and other changes that were applied to the server instance it was created from. Now let's suppose the mill machines actually worked on a schedule. If we want to have all mill machines use this work schedule, we can make the work schedule the default value for the capacity type of the server, along with assigning a schedule as the initial work schedule property. A quick way to do this is to edit one mill, and then right-click to select all Update Properties from this. This will update the mill's object definition, and now all instances of the mill definition will have these values by default. Data can not only drive the objects in your model, but can also create them. Now let's talk about data generated. With a data-generated approach, the model is automatically built from data tables. Like the data-driven approach, the data can also be read in from external files or databases. This can provide a quick start as you begin a project, or help as you expand an existing model, as the data can be easily added to or changed. This allows you to create multitudes of objects with minimal effort. Jumping back into our example model, we have now added in a custom definition for the mill, lathe, and workstation. Let's explore using the data to generate objects. The data tables in Simio can auto-create instances of objects and elements. In a new data table, we can add a column for object reference. Each row in this column is an object instance. This column can reference existing instances, as we can see in the provided dropdown, or this column can auto-create the instances. When we auto-create, we need to specify the object type to create. We can add in a column for the object type so that the instances can be created from different definitions. When the option is to auto-create, as data is added into the column, the object instances are added into the facility. After adding a row in, we can go to the facility to see the object is created. By default, auto-created objects are instantiated at the origin. In our existing model, we already took the time to drag and drop and align our objects on our to-scale layout. When building in Simio, you are also building to scale, so these objects are in realistic locations with the correct distances between them. As we see, the new auto-created objects do not get created at these locations. However, instead of moving each auto-created object manually, we can use the data table to specify the locations these objects will be instantiated in the facility. In this case, we will use the x and z coordinates to define where they are placed, but you could also use longitude and latitude instead. Columns can be added into the table to capture the unique x and z coordinates for each instance. Now, we need to enter data into the table. The objects in Simio record their current locations in the facility. We can look at our original objects to find this data. When selecting an object, expand the General Properties category, then the Physical Characteristics subcategory, and then the Location subcategory to find the x, y, and z coordinates. We can use these values to populate our table. Instead of clicking on each object to collect this, we can again leverage the Properties window. Opening up the Properties window, we can copy and paste the information here into the data table. Notice as I copy and paste, new rows are added to the data table. These new rows are my new auto-created objects. I will add my lathe, mill, and workstation information. I will also delete my original instances from the facility, so now only my auto-created instances will be there. Now my objects are in the correct location, but they are not rotated to the correct orientation. We can change these options from the object column's physical characteristics properties. Here we can adjust the yaw and the length, width, or height as well. Similar to the coordinates, rather than adding in a static number, you can use a table column reference so that each object can have a unique value. We can see that the objects are now facing the correct direction in the facility. We can continue to add information into our data tables and build our objects through data. Next, we may consider adding a table which will auto-create our paths. Similar to our object table, the paths should use an object reference property column. When auto-creating any link object, you will need to specify the starting and ending node. We can add columns in for this information. Here I have added the link data into the table and auto-created the links. I will not do this at this time, but you may also consider using a table to specify the link vertices. This would allow you to auto-create links that have corners or curves. Okay, now we may want to add our workers into a table as well. I can create a new worker table, which will auto-create my workers. Here I have renamed our tables to be appropriately named object table, path table, and now we are adding a worker table. Similar to the other tables, in this table we will add a column that will specify the worker instances. This will be a transporter column. Then we will also add a node column. The workers each have a unique home node, so we can add the home nodes into the data table. Then, on the worker definition, we only need to use the generic table reference. All of the workers' unique home nodes will be stored in the table. Here I will quickly set up the data table as we have done before, specifying the x and z coordinates for the worker instances. This model can continue to be expanded to utilize both a data-driven and data-generated approach. For example, more details about objects can be stored in the data tables. The data table references can become part of the default properties in the custom objects. The object definitions can slowly be built up to rely on the information from the tables. When details need to be added, the data tables create one central location that can be edited. We can continue to add any object or elements we use in the model into a data table. After auto-creating the workers, we can now go and change the home node property, similar to how we've done before. So if I go and change it in one instance definition, I can then right-click and update property defaults from this. Now all workers have the same table reference, and the table reference holds the unique home nodes for each worker. Lastly, the objects and tables you have created can be used as a template in future projects. I'm going to quickly add the remaining objects into the data tables so that we can demonstrate how to convert your project into a template. I want to ensure that the system will have all necessary objects when I load it into the new project so we can see the power of a data-generated model. I am adding the source, sink, and node objects to the object table, similar to how we have done before. Any Simio project can be loaded into a new project as a library, so these custom objects we have created can be used again. However, instead of loading these objects in as a library, we can also save this project file to be opened as a template. Here I am quickly saving my data tables as CSV files. This allows me to store the data in an external location so that I can load it into another project later. Now I am removing the data from these tables so this model can be a blank slate for a future project. I am also clearing out everything from the facility view. Now I will save a version of this Simio project so that it can be used as a template. Once I save and close the model, I will need to add this file into the template folder. This folder can be found in your Simio Programs folder. Once this is saved in this location, I can return to Simio and select New from Template, and the New Template option should be there. When we open it, we can see a blank facility ready for building. We also have our custom objects and our data table schemas. Now we will add a data connector so we can import the files we saved from the previous project. This allows us to quickly pull in data from that external file. This is also where you could experiment with connecting to other data files. Here is our data-driven and data-generated model, which was created and organized by our Simio data tables. The last thing to add is our model entity. Now we can run our model. I hope this has demonstrated how quick and simple a data approach is and the benefits it can bring to your model. I also hope this can help you enhance an existing project or jumpstart your next future Simio project. If you are interested in learning more about data schemas and using templates to build your model, I recommend trying to catch the Simio presentations coming up soon. This wraps up the tips and tricks presentation. Up next will be a Q&A. Thanks for watching.
Hi, Liz. How are you?
Good morning. Good. How are you?
Doing well. Nice to see you. So I have to ask, at one point in that video, when you were copying and pasting into the table, you were moving like lightning fast. So I need to know, was that a bit of movie magic or are you really just that fast?
Oh, I wish I was that quick. That was a bit of movie magic.
Okay, fair enough. All right. Well, we have a lot of great questions. Really enjoyed the presentation. So let's dive right into it. The first question from the audience here: is there a way to have different tasks or different task values for each mill?
Definitely, definitely. So there could be a couple ways you would model this. One way would be you could have an individual table for each mill you wanted to set up, but that would be a lot of data tables, so you might not want to create it that way. Another way would be to use relational data tables. So if you had sections of one table and it defined which mill and which task sequences you wanted to go to that mill, that would be one way you could set that up. So using relational data tables could help out with that.
Perfect. Okay, I was thinking the same. Yeah, so you would have a foreign key, I suppose, in that processing tasks table, sort of mapping some number of rows to each mill, essentially.
Exactly.
Okay. Another example I've seen is where you may have, a category of resources. So you could have a separate primary key for, some subset of mills. So I think this ties nicely into our next question. So someone's asked here, what are some of the benefits of using relational tables? So we just had another example. And are there any examples of relational tables within the software?
Sure. So I feel like there are a lot of benefits to using relational tables in Simio. It's going to let you kind of create more complex relationships in your model, so you can have more complex data structures going on. And when you're going to use those table references in your model, it gets kind of easier. It ties in easier to your objects or other complex pieces of information. So, for example, with the mills, like you said, you could have, oh, my mills have these data table relationships, but maybe it connects to this other detailed data table with more information about things I need to do for this mill. So it just allows you to kind of connect different pieces of information, make things fit together nicely, tie them together well. And there are a lot of examples, I think, in Simio. So I know there are symbits in Simio. You can access them from the support ribbon. And one of the symbits we point people to a lot is the one for sequences. So if you're trying to route your entities with sequences, there's an example of how to set that up with just data tables and then how to progress forward with your data tables to making them a relational data table with other tables and setting that up for your model entities. So that's a good example. And again, you can find that in the support ribbon, the symbits. They're there. They're small conceptual models and they're great.
Excellent. Yeah, I think that's a great way to break it down. And I almost think of it, sure, technically this isn't proper, but like filtering a table, because when you look at the relation through that master detail view, you can see that via your foreign key, you only see some subset of rows in that table. So, I think I've found some other benefits when you're searching a very big table. If you have a relation, you can search, only the rows you really want to search and save some computation time. So, a lot of good reasons to use relational tables, I suppose. Great. Thank you. Next question. So, how can you have different symbols for the same definition? Is it possible?
Yes, yes, it is. So I think A lot of times when we're starting out in Simio, we're building and we're staying in the facility view of our model. And we see there that we can add additional symbols for each of our instances. We've dropped down into our facility, so you can change and add additional symbols there. But as we got into this presentation, we were kind of showing the power of having a custom object. So you can have this custom object that's going to store this information. So in this presentation, it was kind of cool because we didn't go into the definition, but there's so much more you can do inside an object's definition, and this would be one of the things. So you could go into that object definition and you could add additional symbols. So every time you place that object definition now, you'd have this collection of additional symbols, rather than having to add an additional symbol for each instance. So it's just another way, again, leveraging the custom object, you could do this. And if you're interested in learning more about creating custom objects, again, there are great resources in Simio. There's a help page in our help document that talks about creating custom objects. So you could explore that, and it talks about like subclassing or copying and all the things you can do inside of an object definition. So that's great.
Oh, terrific. Okay, and not to go too far into the weeds here, but just to clarify, if you're inside that custom object and you want to add some additional symbols, are you thinking like through the definitions tab, through the external view, or another means?
Yes, so you would want to go to the definitions tab, then to the external view, and then there's another tab in there that's called additional symbols.
aptly named there. So okay, very good. Okay, so another question here in the spirit of data-driven modeling. So here we go. Is it possible to put work schedule and shift pattern information into a data table? And can these work schedules have a repeating pattern?
Yes, you can also put this information into a data table. You can do this in a couple different ways. There's a date time column where you could say this is like the start and the end of my pattern. You can define your pattern in your rows of your data table, and then you can have that pattern repeat. So yes to all of the above. This is definitely something you can define in your data table. And again, this could be helpful if you define it in your data table, because maybe you do want to end up creating these relationships to other data tables. So it could be beneficial, because if you're using the other work schedule type, you can't create those relationships.
Yeah, that's a perfect example. And I think, so for the folks out there listening, this would be in the data tab. You have your work schedules, and there's pattern-based or table-based. When you create a table-based work schedule, it asks you what table, right? And as Liz pointed out, you can have relations into that table. So you have the shifts for multiple workers, for instance, all there in one place. I found this to be really helpful on some projects, particularly if you have the data in this format already. I think that's a really good reason why you might use a table-based versus a pattern-based if you already have sort of a tabular data. Great. Okay, let's see what's next. So here's a question from one of your fans. I remember contacting you via Simio support. What are some resources I can use before contacting support?
What a great question. I mean, we do always love to hear from y'all. We love seeing what our users are doing, and we don't mind the emails, so always feel free to contact us with your questions. But there are a lot of good resources. First, in the Simio application. So you can go into Simio, the support ribbon. There's so much good content in there. So in the support ribbon, as I mentioned before, there's the Symbits. So you can go look at small conceptual models, and those have documentation on how that model was built and kind of the feature that it's showing you. There's example models. So those are more built out models with animation. And again, that comes with a document that'll kind of take you through what that example is showing you. There's our Simio reference guide. So that's our help pages. And that can be found, again, in the support ribbon or by clicking the help button. And then there's books. So we have books and videos. There's books and video button in the, again, support ribbon. And those will take you to, I think, our educational resources. Outside of our application, we also have our Simio forum. So if you're not a forum member, I recommend signing up. We have our Simio Insiders forum, and that just has a lot of good conversation going on between our users as to what they're modeling and maybe other problems they're trying to tackle. People share content there. You can share your objects. You can see what else other people are creating. And that's also where we put our sprints. So if you want to stay up to date with Simio, you can get our latest sprints on the forum.
Terrific. I always say to folks, that we internally, often I do anyways, go to the support ribbon, use the help docs, the example models. The books can be really strong, I think, on the simulation science piece. If you're interested in sort of the statistics, I've found some good help in the books there. Awesome. Okay, I think we've got time for just one more question.
Oh, sorry, one more thing about the books. So again, there's a few books out there. The link would take you to, I believe, our website with our books. And on that website, we also have our free textbook. So that's a resource. I think we point a lot of our academics there, our students use it. So it's our free textbook. It's great.
Yeah, that's awesome. Thank you for reminding me about that. That's a great resource for folks out there. Okay, I think we've got one more question here. A short one. Can you auto create a model entity?
Sure. So this was something I kind of breezed through in my presentation. It is definitely something you can auto-create. You can auto-create any object you want, any element you want. I did not include it in my object table, and that was just more of me forgetting. But it could have been something I put in there, and it would have auto-created the instance of the entity. And you can create multiple model entity instances.
Okay, yeah, I know there's sometimes a decision about, do I use just one model entity and have a kind of different flavors of that using the symbols, or do I have multiple instances of model entity? So especially if you have multiple instances, that might be a good case to auto create them.
Definitely.
All right, wonderful. Well, we're just about at time. Liz, thank you so much. It's great to have you and your expertise here with us today. So thank you so much.
Thank you. Hope you enjoyed, everyone.
Bye.
Bye.
This concludes this presentation. Please click on the back button to access the next presentation.